All right.
Hello, welcome back everyone to 3DQ's weekly live stream. My name is Kevin. I am joined by Mateo. This week we're going to talk a little bit about our beds and how they compare to other options and different challenging print types that you might be curious in terms of how do we slice them, how do they fare on our beds.
Cool. Yeah. So just off screen here, we have a ton of parts that we're going to go over. And all of these parts sort of show a different limit that we were trying to push when we do testing of our beds. So yeah, over the course of this show, we'll be exploring what the limits are and then how that translates to what you can use QUINLY on your printer to do mass printing for.
Yeah. So just a quick note. I know last week, as well as in our Discord, some viewers have been expressing interest in doing some software installation demos. There are some concerns about how to go about installing our software onto a Raspberry Pi or to install the custom firmware onto your Ender. We think it would be a little bit boring and long to do all that on a live stream.
Yeah, there's a lot of downloading and a lot of image writing.
Yeah, just a 15-minute break of uploading firmware.
Yeah.
Get some Jeopardy sounds.
Um, so we'll be putting up soon a separate video tutorial that's kind of edited down for brevity and that'll actually basically be a complement to the
Mhm.
manual we put
Yeah,
up.
so a tutorial that's a little better for actually teaching rather than kind of
Yeah,
like
watching
a
us
like
fumble through it
yeah.
over the course of an hour. So last week we spoke about how to get prints ready for continuous
Mhm.
printing, and this week we'll be talking about what types of prints does the QUINLY print kit support. And so also last week we announced the name of our print kit, which is QUINLY,
Yes.
and we had that part removal demo. Over the course of this show, we'll be showing um, a lot more part removal demos, and then
Hmm.
we've got a couple that will be going up after the show that show like some really complex parts as well.
Uh, So today we're just kind of going through what we're going to talk about. We've got some different type of beds, and we're going to kind of do a bit of compare and contrast. We're going to kind of with that we're going to talk about the limits of our vapor beds, uh, and then kind of going on to challenging parts. What's challenging in terms of generic parts, how those work,
Yeah,
wacky first layers.
a big question with a lot of continuous printing or unattended printing kits is what types of parts can I actually put on this because
What
reliability
kind
is a
of
major.
parts, what kind of materials.
Yeah. So we'll be going through all that. And then at the end, we'll cover, uh, actually, it's been asked a couple of times, but we'll be covering how you prepare, like if you're cycling through a whole bunch of different parts,
Mhm.
how that looks with the unattended printing.
Um, so, uh,
So before we get started, just a couple more things. If we have our stress testing stream, which likes to buffer during this stream because we're using up all the Wi-Fi at our office. But that stream is running as close to 24/7 as we can get it. So if you want to see things for yourself and see parts being printed and
mhm.
looped for yourself, you can always come to that stream. It's Twitch TV/3D Loop. If you have any questions or want to talk to our staff about the kit or about the technology, please join our Discord. We're always in there on non-stream days
So
to answer your
some of us
questions.
might be replying at 4 in the morning.
Yeah,
Some of us might not be.
yeah, don't don't shame my sleep schedule. And then again, we're still looking for more reviewers. So if you're interested in doing a video review and getting your hands on the kit early, we're planning to ship out those review
Mhm.
kits very soon. So please send us a message or an email saying kind of who you are, why you'd want to test out this kit, and then we can see if we can arrange
Mhm.
something to ship early for you. Um, And then finally, early bird 1 and 2 are now
All
all
sold
sold
out.
out.
But we still have a pre-sale going on, so you're not missing out. Price is $97, and you get 3 months free software.
Yeah, cool. All right, so let's get into how the vapor bed, the variable adhesion and automated part release bed differs from other print surfaces you could see on the market.
So I've got 4 different beds here.
Yeah.
Uh, and bit of a jigsaw puzzle. So we've got a flex steel. This is from a Prusa, just a general glass bed. It's got a bit of adhesive kind of spread out on it right now. A build tack plate, and then our vapor bed.
Yeah. So all of these beds have their own advantages and disadvantages. Things like glass and PEI on a flexible steel plate carry the advantage of having really good bottom surface finishes and really easy removal. Because with a flex plate, you take your plate off, you bend it, flex it apart, and stick it back on. With the glass, when the glass is cool, or just in general, glass tends to have
Good.
like is has less adhesion in general, so you get like the nice smooth surface, and it's tends to be easy to remove
Yeah.
unless you're printing something like PETG.
Yeah, and like I mentioned, we've got like an adhesive on this glass. Using PLA on straight glass.
It can work pretty well,
but you do get warping with
yeah.
like larger prints. So that is a bit of a downside if you have to continually like reapply adhesive.
Yeah, like I know the first time on my first printer I had a plate of borosilicate glass, and uh, for some reason, like, and given I was still new at printing at the time, like it was my first printer, but on straight glass, sometimes with large PLA parts, you can actually get uh warping on PLA. So people tend to put stuff like Captain Tape, which is I think polypropylene backing, and also the blue painter's tape
Yeah,
to do
blue
printing on that.
painter's tape.
So yeah, glass is good for finish, but it's not necessarily the best for adhesion. And then next we've got kind of the Ender 3 build tag. These types of rough surfaces tend to be made of something like polycarbonate, which can offer extremely impressive adhesion, but you can see only a single print was done
So
on
you can
this.
kind of see the reflection. There's a little bit of residue, a bit of scratching. Uh, and that's just from, yeah, like you said, 1 or 2 prints.
Yeah.
So really high adhesion can work great if you just like got something that's super challenging, but
Yeah.
you do have the issues with trying to remove it sometimes, and also the rough bottom doesn't give you that smooth surface finish that you kind of get on glass.
Yeah, and as we've discussed before, like if you overcompensate for complicated parts by having insane adhesion, that always introduces problems towards the end of the print, because small features and delicate features can end up becoming damaged as a result of like flexing the plate or trying to scrape the part off. And then there are also a couple beds that we don't have with us right now that we'll talk about, which is the it started with the Anycubic Ultra Baits, which is a ceramic coated glass surface that uses those little dimples in order to grip parts, and those are really good in terms of providing high adhesion when hot. But then the problem is, because it's a mechanical type of adhesion, because it's textured, it actually tends to smooth out and wear over time. So you see people having to like run over it with abrasive after a couple of prints.
Interesting.
Yeah, and it depends a lot on the material you're using too. But yeah, so we can kind of compare to that as well.
Do we have any other beds to talk about?
Yeah, there's the other bed that somebody brought up and thought was actually what we were using for our surface was a polypropylene.
Right, very similar color.
It's a similar, yeah, I didn't actually know because when I looked at polypropylene, they used to be kind of like a milky white,
Mhm.
but now I guess some of the brands have switched it over to a similar green to this. Um, Polypropylene is actually quite good for some more standard materials, but we can assure you that the vapor bed is not based on polypropylene. It's
Mhm.
actually a custom formulation again that we've been working on for a number of years now.
Yeah, so it's our variable adhesion bed. Let's talk a little bit about our vapor bed
Okay.
and kind of compare it. So we've had hundreds or thousands of hours, like many thousands of hours, printing parts on these. If you've seen some of our videos, some of our achievements, like we've mentioned previously, like a thousand headbands in 1 week. Um,
1,000 hours of printing
Sorry,
headbands.
yeah, and about 900 parts. So we know they work well and they work
Yeah.
consistently.
Some of the oldest beds we have, like the oldest bed I have still at home, on my original like prototyping printers is was in heavy use for 2 or 3 years
Mhm.
and still survives to this day and has basically the same surface qualities as when it
Yeah.
was new.
So you can kind of see from the sheen that it does have a pretty similar smooth surface and consistency to glass, which is quite nice. You got that smooth bottom layer just for looks, or if you want to do writing at the bottom, it does. We found it does come out quite well.
Hmm.
Uh,
Yeah, it's kind of like you get the surface finish of glass.
mhm.
Like if you look at some of the larger parts here, you get this really nice.
Almost basically it's got a slight sheen to
Yeah,
it with
it's got
the
a nice sheen, similar to glass, except then it offers adhesion properties that are comparable to stuff like the like Build-Tack
mhm.
polycarbonate, but then it also offers the release properties that you get from
Yeah.
printing on something like
So
bare glass.
So if you joined us last week, we did a force test where we had a small, like about 3 centimeter cubed part.
3 centimeter by 3 centimeter square footprint.
Yeah, and then we pulled a force about 2 centimeters off the plate, and we got up to about 6 kilos. So that's at high adhesion, and that low adhesion, I was able to push it off with a rolled up sticky note.
Yeah, so I think for that as well, we're going to be publishing another kind of more close-up video of that
Mhm.
test as well, coming up. But yeah, that was our live test for it. So you get really impressive adhesion strength, and we'll talk about what types of parts that lets you do, kind of as we go through our test parts. Um, but yeah, so it's kind of a best of a couple different worlds. We tried to incorporate the different like a lot of people have to choose between the type of bed they're going to use based on their use case. So we've
Mhm.
tried to incorporate the best properties of different beds in order to be able to cover the most amount of use cases.
Yeah. So with that in mind, let's talk about a few of the prints that we have on hand in terms of variety of what you can achieve with our vapor system on QUINLY.
Hmm. Yeah. So just just before we move on, so this the Vapor system again is an upgrade for
Hmm.
your printer. The QUINLY kit is an upgrade. So, in order, not only do you get the benefits of having this great bed, but this bed allows automation, and it's automation on your printer.
Yeah. So
So you're not buying a new printer in order to have
I
continuous
don't know. It's
manufacturing.
still the same baby that you had before with whatever mods you've added. So you're not losing, whatever printer you've put hours of and lots of money into.
Yeah. So, yeah, let's get into the parts and as we go through these, it would be interesting to know like what the most difficult parts you've encountered are, and if you really want to, if you want to send us some tricky parts so that we
Mhm.
can test it and take videos on the Vapor build surface, um, you can either send it to us through our Discord or get in touch with one of us and maybe you'll see it on the looping live
On the
stream.
live stream, yeah,
Yeah.
you can see it in time.
Okay, let's start with kind of standard parts. So Yeah, let's just pull a bunch in here.
Got our classic
The classic
Benchy.
Benchy.
Classic Benchy. Just
I'm gonna grab the visor too. So these are kind of,
a little dark, but we'll show them.
yeah, these are sort of standard 3D prints you can expect. So we'll start in the middle and kind of work our way around the different types of limits that the bed can encounter. So kind of in the middle, this is just to show that you're, well, it's a good demo of that the slicing doesn't really
Yeah,
change.
so these are like some fairly simple first layers. This Eiffel Tower's got some tricky overhangs, but in general, they print exactly the same as on your normal printer.
Hmm.
Uh, so like they all come out the same. We haven't sliced them any differently.
Yeah.
What we have done is use the material profiles that we've built up to do these prints well on the first try.
Hmm. Yeah, so like we've spent we talked about it quite a bit last stream, but we spent time developing material profiles, and now with these profiles, whether we're printing on the QUINLY, the vapor bed, or we're just printing on a standard print bed, the slicing doesn't change.
Mhm.
You don't have to make compromises to your slicing profiles that you've worked really hard on in order to use the continuous unattended printing that the QUINLY kit has to offer. Um, with some other types of kind of automated part release or fancier printers that facilitate part release that use complicated mechanics, you actually do have to look at modifying your slicing profiles because the actual geometry of the printer can be different. And in a lot of cases, when you want automation, you have to buy a special, a purpose-built printer for it. Whereas with the QUINLY kit, it's bringing the automation to your printer.
Of the
Um, Yeah, so why don't we talk about this? So this is a fairly easy part. It would be easy to print on any
hmm
printer. But it's a really good example of the mindset change that you have to
Yeah.
have when slicing for now, not just getting a single part out, but when you're considering an entire production run.
Yeah, so considering my time working in an engineering lab where I've got tons of different prints, I don't have much concern for quality. I just want to get prints out the door. I've
Hmm.
got some generic prototypes. I've got maybe a bit of a material profile so I can kind of do my best to print them well. Uh, but because every print's going to be a little different, I don't need to focus on optimizing them. Uh, but coming to this automation, you know, every second is multiplied by like 1,000 or 10,000 or however many prints you're doing.
Yeah.
So it is really, again, important to spend that time up front, even with simple parts. It's especially important because because the parts aren't tricky, it's easier to make compromises to save time
Yeah. Yeah.
and post process.
That's a really good point. It actually reminds me of a discussion I had with a lab operator at a different university where their goal is just not to have the part fail. Like, what is the minimum amount of slicing optimization we can do to just not have this next part fail? And when you're doing kind of one-offs and when you're always with the printer, that's acceptable because um, there's not really any need for regard for a longer term cycle. But if you take that same philosophy into um, print looping and an actual high volume or higher volume production printers, or even just unattended printing, you want to spend that time up front making sure that three prints in, you're not going to have a bad print that
hmm
might mess up the rest of your print queue. Um, and it pays dividends, like you said. Any small optimization now is multiplied across your entire production run. So maybe just to reiterate, when we did the 1,000 hours of this,
hmm
um, we did spend a couple hours up front optimizing this headband, and it actually took the print time from 75 minutes to 35 minutes.
hmm
But the other really interesting thing is on just how little operator time the production run actually took. So it was 1,003 hours for the entire run. It was almost 900 parts.
Yeah, and only 3 hours operator time,
Yeah,
mostly to change filament.
yeah. Half of it was to change filament, and half of it was for printer maintenance. None of it had to do with um, fixing failed parts. And
Yeah.
so like spending that time preventing as many failures as you can. And it's really, when you consider the scope of it, how much time you save, spending an extra hour or two, doing a couple extra iterations before you let it chug over the course of a week, um, really ends up like it almost pays back exponentially, because yeah, you save a minute here, and then you save a minute on your slicing, it saves you 1,000 minutes across your production.
Yeah, so anyway, those are kind of generic parts considerations. Um, like they're easy parts to do. You can do them on your normal printer, and you can do them on QUINLY. But on QUINLY, you know, you can ramp up your production. You can do 1,000 of them, and you can do them all the same.
Yeah.
Just
we can leave them here.
Yeah.
Okay, so let's get into oh, I forgot to show a cool video of the headbands being released. So here's a video
from our live stream.
Yeah, this is taken from one of the earlier runs of the live stream. We've also got the Eiffel Tower here. Sorry, I should have been playing these while we were talking. But yeah, it's basically kind of a proof of concept that the same slicing profiles will carry over. You don't have a massive learning curve to get used to new hardware.
Oh no, like the hardware is pretty much the same. You don't have to do anything other than slice it and let it run.
Yeah. There's a really I really like the oh, actually we'll get back to skirts towards the end.
Yeah.
That's actually a really good thing to talk about.
But yeah, that release though, like
it's pretty good.
It just slides off.
Not to pat ourselves on the back.
I'll do it for you.
Thanks. My favorite is the benchy though. Like, look how smoothly that comes off. And again, it's kind of, it shows that we're not smashing the parts off. They're literally disconnected from the print bed once the bed gets...
just maybe a little bit of static holding them on.
Yeah, it's literally, you just have to overcome the friction of the part sitting on the print surface. That benchy release is one of my favorite ones. Okay, let's move on to complicated first layers and more extreme prints, like actually starting to push the limits of what the bed can do. So why don't we start with which one do you want to start with? Do I start with the comb?
Yeah, sure.
Okay. So the comb is basically a bed torture test that we kind of do to validate the performance of the bed. Yeah, why don't you tell us a bit about it?
So this is a one-layer test that has, as you can see, it's kind of like it's the shape of a comb, and that's got all these little parts kind of sticking out. And the goal of this is to show that or most points across the bed have good adhesion and consistent adhesion, because these little extrusions, they have one line that goes out and another line that comes back.
It doubles back right
away. Yeah,
away.
and if your adhesion isn't the best, what you get are kind of little contraction forces that like to pull up the edges. So as you can see in some of these ones,
this was a failure that we wanted to show
like
you.
not even just the pull back parts, but just even the main lines, they just don't adhere well.
Yeah.
And so that can happen, you know, if you've got lots of fingerprints on your bed, if it's dirty, it's scratched.
If it's unlevel. This is actually like one of the most torturous leveling tests that we run, I think, on some of the printers. But we actually do this in terms of we also do this to test beds before shipping them out, which I think is important to note. Like, all the beds we test them to ensure that they have adequate adhesive properties. So this is one of the tests that we run on it before. And just something interesting I noticed, because you were talking about residue from like oils and fingerprints. You can actually see there is a lot of residue on this print surface. Or it looks like
scratches too.
Yeah, I think these are, I think like it wasn't wiped down properly after cleaning, and that's probably what caused that one to fail. So it is, and it'll be explained in the manual, but proper maintenance of the bed is basically the key to it functioning well. And maintenance is extremely easy. It's as simple as don't pour canola oil or your finger oils on the bed.
And no solvents.
Yeah, and don't use solvents to clean it. Just soap and water is enough to clean it. As long as it's not dusty or oily or gross, like it doesn't have like maker gunk all over it, the bed will perform as required, and the performance will like last. It doesn't wane over time as you might see with other different beds. Again, that's a function of how the actual part release works. But as long as you keep it clean and you keep your oily fingers and elbow grease away from the
Ooh,
printer.
yeah, no elbow grease.
Yeah.
The QUINLY does all the work for you, so you
Yeah.
don't need any elbow
Yeah,
grease.
you don't need to be touching your printer if QUINLY is managing it for you. Exactly. So this is a pretty impractical print, but it is a torture test. Maybe let's move on to
some more practical,
something a
difficult
little
prints.
bit more practical. Yeah. So why don't you grab these? Are always really fun and probably super loud on the mic. This one was printed last night, and we'll be putting up a video of the release. But everyone who's done 3D printing has seen chainmail, which is essentially like hundreds of individual interlocking parts, and it can be a first layer nightmare, right?
Yeah. Yeah. Again, like you get all these little lines doubling back.
Yeah.
You got really close tolerances.
Let me show the camera while you talk about it.
And like a little pizza. So as you can see, that one was printed on our vapor bed up front just last night, and you can see it's got that sheen on all the different parts. It came off quite nicely, almost flawlessly. But on a normal printer, I think Mateo's talked about this before, it's a nightmare to come off because
this one was printed on
you've got so many different spots that you get like it's not like one part where if you get one corner, the whole thing. You got to get each individual little piece to come off.
We have a video of like a that we recorded way back of like a time comparison. And the thing with these, like a PEI build plate will work if you flex it enough, but the thing with I printed it on one of the polycarb surfaces.
Yeah.
And bending it, the chainmail actually bends with the
yeah, like
so
even on a
like
flex steel, like bending doesn't do anything because it's not stiff. Like
Yeah.
each little part kind of just moves with it.
It was a major pain, and I have a video of how long it took to scrape. It took me for this one, it took me 23 minutes to scrape it off, like with the paint scrapers. It was such a pain. And the other thing that would have been like, so this is an extreme example of having a lot of tiny contact points on your print surface, which the adhesion does well with, but there's also this added dimension of what if a print fails that has so many contact points. And I was printing a different version of chainmail on I was printing it on that it was on a glass surface on my Delta, and that one had each link had four contact points. It was like a little loop, and the links were much smaller. I think it was like around 3,200 little contact points that are literally just dots.
Oh my.
And I had it fail like 95% of the way through doing the first layer.
So you got all these tiny little dots.
None of them were connected. They were like little tiny little like
little blackheads on the
like
floors.
yeah, like little gross grains of I'll say grains of rice. And removing them from the glass was awful because I had to use like PVA glue.
Yeah. You would
it was such a
You would have
disaster.
been better like just putting like a large one layer on it to remelt.
Yeah, I should have thought of that. Like it happened to me on a smaller sample on the ender bed, and I just gave up on trying to scrape it off. I literally just printed over it for the next couple of prints and had the other prints take them off with them. With the vapor bed, I that type of failure would be much easier to clear because they're not stuck to your
No,
surface.
you can just wipe them off. Like
Yeah.
they might not be able to clear with the
Yeah, I think it'd be probably too small to clear and
yes.
take too
So
long.
like with our current settings, one layer is too thin
Yeah, and we'll
to
talk
come off.
about that too.
But it's easy to clean anyway.
Yeah.
So let's move on to some other kind of challenging prints.
So yeah, what is a more practical application of such like convoluted, complex first layers? Um, what's this?
This is a little case for the buck converters that we actually put on all our production machines. So there's two halves, top and bottom, and what's interesting about them is they have a really interesting, intricate first layer.
Yeah, and hexagons seem to be very popular among the maker community in terms of designs. Um, so yeah, like if you can get something like this dialed in on the vapor bed or any print surface,
You
things
can
like this become really
and you
easy.
can print pretty much anything
Yeah,
else.
yeah, exactly. So like this and the combs really push the limits of calibration and how the bed can perform, and then that makes it like really easy. I like to imagine the limits as being like a big perimeter, and the farther you can push that out, the more parts fit inside.
For
So
sure.
this is like in my mind, this is sitting
Pretty on
about
the outside.
yeah. This is sitting just like just a bit inwards from something like this or from the cones or for the cone print. Um, do we have any ear savers with us?
Not in this room. We did have
We
one
do have
printing
a
on the live
Yeah,
stream.
we do have a video. So the ear saver is kind of as we transition from the area of complex prints to the area of thin prints with complicated first layer. The ear savers are a really good example of that. So why were we printing ear savers, Kevin?
Uh, ear savers, kind of like we mentioned, or kind of as we were talking about, are really thin parts. So these aren't one layer. These are, I don't know what the quality was. I think it was a pretty uh, thin layer
I
height,
think they're 4 layers.
4 layers. But they're about 2.5 millimeters thick, and so they're really lightweight, really thin. Uh, so adhesion is kind of a big issue because you do get those edges that double back and can cause peeling if you don't have a tuned or clean bed.
Mhm.
Uh,
I think it's a really good showcase of the release properties because really thin prints are a nightmare to do on beds that have high adhesion.
because you can't get them all. Like if
You can't flex them off, so you do have to resort to scraping or peeling
yeah,
them.
like if you peel them while they're hot, they
They
deform, and
deform.
if they're cold, they might even snap.
Yeah. Um, so it'd be interesting, yeah, if any of you guys have any kind of oh, thank you, Joe. Here are a bunch of ear savers.
Yeah.
Um, yeah, like if you have any if this is giving you any ideas of maybe other prints that you've had that kind of resulted in certain frustration with the print surfaces, because yeah, these things are
You can
ridiculously
see how
flexible.
floppy they
Here,
are.
I'll switch back to the main camera. They're very, very thin. And despite that,
Thank
despite
you.
having a high surface area to the part that when the adhesion is released, they're able to just cleanly slide off. Yeah, I really like these as a demo.
So what's our next part? We've got
Oh, sorry.
chainmail butt converter, ear savers, big and heavy parts.
Okay, so we talked about complex first layers. Now let's talk about heavy parts and kind of the limits of the weight that the vapor bed can support. So, um, as you might know, on our production system, we actually mount all of our printers sideways so that we can take advantage of gravity for the purpose of clearing the parts out of the way. And the kits themselves are actually, it's hard to tell from some of the video, but the kits themselves are tilted at a 30-degree angle. And the reason for this, again, is part guiding. But the reason we can even tilt it at all is because the adhesion
It's so high when it's hot.
yeah, that you can actually counteract any sort of forces of gravity that might be acting on the part. within reason, right?
With yeah, you don't want to just
Like
print like a
a
five
single dot.
kilogram spool into.
Yeah,
Well,
like
I don't know if that's physically possible.
no, yeah, it tends. I don't think we were looking at like what is the heaviest part you can do with the minimum contact area, and like if the
Like do like a little diamond.
yeah, you'd basically have to build outward as much as you can on like a tiny foot, and that's pretty unrealistic in terms of the parts I've seen done on printers.
Mm-hmm.
So I think on in that respect we're pretty safe. But a really cool part um, that we do have is the side guide
Mm-hmm.
rails. So how are these printed, Kevin?
So these are actually printed standing up. I don't know if you can, like so.
There you go.
So they print from this little base right there. It's pretty small, and flat and thin, but it's quite tall.
Yeah,
And
I've actually got a video here.
we should have a video. And so even at an angle, the height of these does lead to a fair bit of force going downwards. That you know, as the bed cools, it doesn't even need the extruder to push it off because the gravity actually pulls it off because of the small surface area and tall height. But the adhesion at the high temperature just, you know, holds it on so well that, you know, we don't even need to worry about the effects of gravity because these even print at 90 degrees.
Yeah, that's kind of interesting. We do print them on our production systems fully at the 90
Mm-hmm.
degrees. So it's literally sticking out almost 20 centimeters on this tiny contact area. Um, yeah, so here's one printing on the demo kit. He gets so tall it comes out, it falls out of frame. We do have another video that we'll be posting of the whole thing, but you'll see it as it comes down.
You can see there, the z-axis didn't even come down because the gravity just fell
Yeah,
off.
it actually, yeah, the gravity was enough to take it off. And again, that is a pretty good display of just the contrast between the high adhesion and the low adhesion
Mm-hmm.
states of this of the vapor bed. Um, yeah, it's funny. I know who
Yeah.
told us like we need to add guides for these parts that are
So
gonna be falling.
after this part actually fell, like in the video there, I'm like, hey, if only we had some
Additional
part
part
guidance panels that
yeah.
we could put on. Uh, so you know, in some of our later videos, you do see those added
Yeah,
on.
we threw them on the side so they wouldn't like fly off onto the floor for the heavier parts. Um, yeah, and we can talk about that too, like what the ideal part guidance is, especially with these bigger parts. So, in terms of another big and heavy part, we've been printing vases on our printer, and those actually are a good example of a part that has not only large, yeah, not only large, but actually has a really big contact area
Yeah,
at
it's
the bottom.
big and flat.
You have the black one?
Yeah.
So this one's a little thinner, but you know, big, flat, heavy.
And so with parts like this, on a regular print surface, getting it, so this is a really thin base layer.
Mm-hmm.
Getting something like that off can be pretty tricky, just because you don't really get a lot of leverage, especially these ones are quite flexible.
Like yeah, like because they're tall, you do get a fair bit of force if you kind of.
But the single wall prints, like if this
Yeah,
was
like
on one of those
this actually
beds,
cracks if you pull
yeah,
it.
yeah, this would actually break. So yeah, those are some pretty massive prints we've done. Here's a video showing one of these being printed completely horizontally, and release and how the release actually works for something that large. Oh, one sec. Hmm. Oh, here we go. Excuse the technical difficulties. Base. There we go.
Yeah.
So this is just after printing. This is actually on an Ender 5 that I had at home.
Oh wow.
So,
Ooh, it's slipping.
yeah, so the release just happened, and now you'll see it's homing, and it'll just kind of slide it off. You can see there's like the vase isn't completely deforming because of the force pushing
Yeah,
it off.
it's just sliding
It's just
right
getting
off.
displaced. Yeah. Um, and so yeah, I guess that's a bit of a proof of concept of doing really heavy parts and going back to that demo, we were getting 8 pounds per square inch of force. So doing large parts that fill your whole build area is actually not really that much of a problem because they tend to have big bottom surface areas.
So if you have, for some reason, you want to print 1,000 big heavy vases and you have the filament, QUINLY lets you do that. As you can see, you
Yeah.
just, it falls off on its own and then starts printing the next one. And you can do that too with your QUINLY kit.
Yeah. I can imagine this having quite a lot of application in terms of interior design.
Oh, absolutely.
One of the interesting things about this vase is the pattern on the outside is completely oh, let me switch back to you. It's completely it's procedurally generated. So one of our designers, Richard, has created a program that can basically give you infinite variations of these. And like imagine how cool it would be to have a product line where every single product is slightly unique.
Slightly different. Yeah,
Yeah.
that's pretty cool.
Um, and then kind of our last example of a print, before we move on to how helpers like rafts and supports work is the long box. So the long box is a much smaller print, but it's still got a massive surface area. So in case you were thinking like, oh, the leverage of the giant part is what helps detach the print from the surface. These ones, there's almost no leverage on the giant build area, and these ones it took us a while to dial in because they had to be so precisely printed
and just to look good.
Yeah. But yeah, so here's the kind of a counterpoint to anyone who's like, oh well, it's just because it's a heavy part, it's gonna pull itself off. Yeah, okay. So if anyone has any kind of questions about different types of parts, please send them to us in chat. Otherwise, why don't we move on to supports, rafts, skirts.
Extra material other like outside of your part.
Yeah, basically helpers. I think that's how Kira calls them, helpers for your print.
Yeah, so when we're working with production products, we rarely need to deal with supports or rafts because of the high adhesion that the vapor bed provides. Sometimes it is necessary just for quality's sake or with unusual materials. But what kind of prints would we need those for?
They tend to be, so I've got an example here. It tends to be a print that has like a really weird shape, or that we're going for basically using the resin method of printing to get some really nice surfaces on a complex surface. So this here is actually an example of one of the prints that we did do supports for. But something to think about is because you're now not looking at single parts, but you're looking at series of parts, and you're basically, because QUINLY is handling all the print management for you, you're left to deal with all of these parts and any sort of post-processing associated with them. So even though we did use supports to get some nice quality out of this part, we try to avoid supports as much as possible, because in the same way that saving any time multiplies across your entire production run,
adding any time just adds to the production
yeah,
by whatever multiply.
And so these were interestingly are not generated supports, but were manually designed.
And what's great about these ones here that are designer made is they're so easy to break off that you can pretty much take them off while you're doing collection. So they don't really add much time to production. But they do increase the quality of the print. So it is one of those times, due to like just the shape of the print, where some helper is necessary.
Yeah, exactly. And like under normal circumstances, spending that extra time designing the helper is really doesn't make sense because you're not going to be doing that many, and you can just deal with uh removing them like once your prints are done. Like while you're waiting for the next print to finish, you can be cleaning up your part. Um, when we're looking at doing like hundreds or thousands of a part like this, it does make sense to actually try to minimize that time. So these specially designed supports that Richard made are made specifically for this part, but also just to break off very easily. And again, it's specific to this part because there's major advantages
Yeah.
to having that. It can't be emphasized enough that you have to think about. You're basically going from a prototyping mindset to a manufacturing mindset, where now you're thinking about how do you get QUINLY to run the printer for you for as long as possible, because you don't want to do any of that,
Yeah,
right?
you know, that's QUINLY's job.
Yeah, that's QUINLY's job, exactly.
So when would you use wraps? Like, you know, typically wraps are used maybe on glass if you're using PLA, just any kind of large print where the corners might lift, or maybe a small surface area print.
Yeah.
You know, on the vapor bed, you know, I don't think I've ever seen a print use it, but is there a situation where you would need more helping adhesion?
Yeah. Yeah, it's very rare that we use it because of the post-processing time it adds. But there have been some cases where we did have to use rafts for the purpose of adhesion. And like you'd hinted at, it's when your parts have a very small contact area. And it doesn't tend to be like I have two cases in mind. Both of them were printing with nylon material. One of them was a very, very heavy tube that was printed in nylon. And the thing with the tube is, because it's a tube, you only have a ring of a contact area.
Yeah, only like one or two layers.
And I think that tube was like 350 or 360 grams, because it was printed at almost full infill. And so I actually got one to print with only the tube contacting it. But then going back to thinking about long term, the next two I printed, it would detach about 80% of the way through. So in that case, I added a really quick raft that just expanded the base of the print, and so that would have been a case. The other case with that nylon material was the client had asked us to print a massive box, so it was like a 22 centimeter cube, but just the walls. And the walls were about 8 millimeters thick, and it was printed with a 0.8 nozzle. So the nozzle was going around making loops as it was building this box up. The box is completely hollow, and nylon, when it's cooled unevenly, really likes to warp.
Pull in on itself.
And so you basically had these massive, like 20 centimeter long walls, just providing, and it like I studied it, and it looks like just the fact that it was being printed in loops actually affected how much and the direction in which the warping was happening. Yeah, it was really it was an interesting learning experience, but as part of that, I had to expand the walls, the contact surface with a raft, because the force was so high
over a small area
that it was actually causing warping. It didn't cause it to detach, interestingly, but some of the corners, so it was like 22 by 22 by 23 centimeters. Some of the corners warped up like 3 centimeters towards the end of the print. And the craziest thing was, we were printing it in a heated enclosure, and that material, like that nylon material, experienced so much warping that it had pulled itself apart. I took it out of the enclosure. So obviously,
interesting.
Yeah, like, and as we transition into materials, like enders are not suited to print like objects
with like 110-degree bed.
In nylon of that size, because they're not enclosed.
Yeah, just before we move on, we do have a good question here about brims. Asking, how many lines do we recommend for brims? So we did briefly mention brims before.
Yeah.
We actually try and avoid brims as much as we can.
Despite what the
This,
stream might
yeah,
show
so
you.
in production, we definitely avoid brims like with our headbands. We didn't want to have to post process 1,000
Yeah,
parts. With those one-time prints, we just had to happen to slice them from muscle memory with brims.
yeah,
The only issue with brims, it's not an adhesion issue most of the time. It's more just that pre-fill, the priming of the nozzle and the filament. Because at your first layer, when you're coming in, usually you get a bit of dripping after your last print, so you need to kind of prime the nozzle. And that's the only really real reason. Like, you could do a single line. We have designed this little cylinder that goes in the corner.
yeah, yeah. Why don't we talk about strategies to get rid of brims? So you can see on this video is like exactly what happens when you use a brim and don't have it calibrated perfectly. The part will come off, but the brim won't go with
Yeah,
it.
you can see it lifts off, but like just the first corner that it went down, just kind of kept it behind.
Yeah, it's too light and it stays kind of it clings to the surface like how saran wrap might cling to something. So the the strategy with brims is what we do for like one-off parts where we don't want to design a brimless solution is we make the brim distance basically I think it's like um, if your nozzle width is 0.4, we make the brim distance 0. I think 3.5.
Yeah, so
So
just under the width of the nozzle, so you get that light
so
contact.
yeah, so it's contacting it, and in most cases, it wasn't done on this part, but a lot of the times the brim will come off with the part, but the distance will be enough that you can easily strip it off. As soon as you start doing any sort of volume, like Kevin had mentioned, it makes sense to look at alternatives. So one of the things we did with the headbands was we had a line in the middle of our bottom infill that would prime and actually then print the serial number. Um, and then so once it started doing the outer perimeters, it was already primed. It had already printed a little bit. Um, and what was really cool was like the serial number essentially became our priming mechanism. And then for a different order that we were doing, there's those towers where you put like a little priming tower in the top right corner. And I think this is actually a default setting in Cura, but it would be worth looking at doing something a bit more customized. Um, the can we see the priming line? Oh yeah. Do you want to click on the priming
We
line?
had a really good one. I think it's up here.
Take down the
Do we
office.
still...
So yeah, you can do a priming tower too. That just gets knocked off when the part is knocked off as well. Yeah, this is a good
So
one.
this is a really cool example because we had actually switched filaments just before this first print. So you can actually see the previous color as it kind of transitions. So it goes from the black to the silver. You can see that line on the bottom as it turns into the serial number.
Yeah, yeah. So you can like hide your priming lines basically if you want, and then yeah. Andrea was very happy that she didn't have to be like ripping the brims and skirts off all the time.
Anyway, we're kind of a little short on time, so let's move on. We did briefly talk about materials. PLA, ABS typically work pretty well with the high adhesion and easy removal.
So and what we mean by that is we basically have developed internally for our enders generalized profiles.
Yeah, so those material profiles aren't just for brands or color. Any type of material. I know you might have more drastic changes in terms of temperature and feed rate, but in general, it's just more profiling.
Yeah, yeah. So we start with a base profile for a PLA and then we'll optimize it for different brands. But we have general profiles for most PLA and ABS. Then some of the other materials that are compatible with the bed, but we're still doing testing on, are things like nylon, polypropylene, and polycarbonate. And the reasons that we don't have general profiles for those and haven't been able to do all the testing we wanted is because they require quite high temperatures. So we've done like proof of concept for the adhesion and the release. Nylon sticks really well at right above 115 degrees Celsius, which on an Ender 3 is really hard to
Yeah,
maintain.
it's just not built with that in mind. Like, of course, there
You
are
can
mods
mod it,
available,
yeah.
and if you do the modifications, Quinly can accommodate that, and
Yeah.
you can run it as if it was a normal print.
Yeah, and yeah, same thing with polypropylene polycarbonate. We were able to get successful adhesion and release, but again, the temperatures are like right up at the top or even outside of the range that the standard ender heaters could hit. Um, and then there are some materials that are extremely variable between brands and colors, like PETG or HIPS or copolymers, which is literally just a class of plastics. There's no specific formula for copolymer. So we've done testing on all of these, and what we found was we couldn't create general profiles, but we were able to create profiles for specific versions of the
Yeah.
material. So if you're planning to do any printing in those, just keep in mind that you'll probably have to, whenever you get a different brand or even different colors, you'll have to consider that your old profile might not transfer
And
over.
so something to consider too is if you're doing production of thousands of parts, you may even notice a slight quality difference between material batches. So, same brand, same
Yeah.
color, you might notice it prints a little differently.
Yeah, so what we did, like because we do print so much, what we end up doing at one point was literally just buying a couple 100 kilos of material that presumably all came from the same batch so that we could be quite confident that replacing filament is
Wouldn't
not going to
change.
mess
Yeah.
anything up. Yeah.
So we're almost done here. So we'll kind of close up. Like we mentioned, coming soon will be our kind of software and firmware setup video. Like I said, a little boring and long for a live stream, and it will be something better to keep as a long-term resource, as you guys are putting together your own kits at home. So again, with that, how do you get your kit, Mateo?
Yeah, it is available on our site at 3dq.com. It's still in the pre-order phase. Early Bird 1 and 2 are closed, and it's available for $97. That includes 3 months of the QUINLY printer management software subscription. So that's kind of like a pre-sale bonus. You also get some extra goodies like like spool holder hardware, because we found your spool holder, when you're printing that much, actually starts to matter in terms of the
Yeah,
quality of
yeah.
your prints. Um, so uh,
Next week
next week,
we have it's Remembrance Day here in Canada. Uh, so
there will be no live stream.
no live stream. We encourage you to attend a virtual memorial. Otherwise, we will see you in a couple weeks. So for our next one, we'll be doing tabletop board games.
So we'll be bringing in a couple people who use 3D printing for tabletop gaming, and we'll be talking about kind of how they use 3D printing in their work, what their workflow looks like, and especially if they're doing higher volumes, as like because board gaming is pretty massive, and 3D printing has been an amazing boon for prototyping new games and getting new pieces. So we'll be talking to a couple people about yeah, about how they use 3D printing and what it looks like to use it kind of as a for online marketplace type use
Yeah.
case.
So once again, join our Discord if you have any questions or you want to follow up. If you're interested in reviewing, again, just shoot us a message if you're interested. Let us know, what your skills are and how you can kind of help show off the potential of QUINLY. So yeah, our early bird is done, but our pre-sale is still open. So make sure you get your orders in soon if you want a kit.
Yeah, you can find that again, 3dq.com right there. Yeah, and if you have any further questions or just want to chat with us, please join our community Discord. Someone is always in there. You can talk to the engineers behind the tech and they'll answer all your questions. Yeah, so until then, we'll see you 2 weeks from now.
Yeah. Have a great evening, guys.
All right, bye-bye.